Let's get started with a practice problem. Maybe one of our amazing professors can help us out.
So, for our business, the price of our product, P is the price, Z is a constant, e to the kx. K is a constant, and x is the number of units sold. So, we need to solve for C and K, our two constants. The way we're going to do that is, we know that $45 and 1,000 units are sold in this equation. $40, 1,200 units sold in this equation. So we have those two equations, we wrote them out. Now we're going to solve for C and K like so. So what we did next is we solved for C by dividing e to the 1,000k over 40 in our second equation. So C equals 40 over e to the 1,200k. We plug that into our first equation right here. So we got 45 equals 40 over e to the 1,200k times e to the 1,000k. Should be k, sorry. And then we simplified the equation, so you got 45 equals 40 over e to the 200k. We went one step further, brought this e to the 200k to the 45 side. You got 45 e to the 200k, divide both sides by 40. E to the 200k equals 40 over 45. So we divided both sides by 45 to get k by itself, and now we have e to the 200k equals 40 over 45. Over here, we use ln to get rid of the e's, so 200k ln of e equals ln 40 over 45. Ln of e cancels out. So from there, after we got rid of ln of e, we have 200k equals ln 40 over 45. Divide both sides by 200 to solve for k. K equals negative 0.0005889. We then used k, plugged that back into one of our original equations, and we found that 45 equals c e to the 1,000 and then k. And right now we're solving for c. So 45 equals c 0.55494, divide both sides by 0.55494, and c 81.089848. Okay, so here's the real calculus stuff. Remember our original equation was p equals c e to the kx. Well, we found c, we found k, and p and x are the variables. So what we want to do now is find the function that will maximize our profits. So to do that, we find the derivative. When we have an e equation like this, to find the derivative, we bring this number right here, find the derivative of that, and multiply it by our base number. And the derivative of p is 0.0478 e to the negative, and then that. Done.
Businesses make use of exponential functions in order to create demand functions for their various products, like this one here. The demand function of a certain kind of product is given by the function d of p is equal to 480 e to the negative 0.003 p. Step A. How many trash cans will be sold when the price is set at $120, $180, and $340? To solve, simply plug in each value to the p-value of the given demand function. Step C. Find the marginal demand. To find the marginal demand, find the derivative of your original demand function. In this case, simply drop your exponential value and multiply by 480, resulting in your marginal demand function d prime of p equals negative 1.44 e to the negative 0.003 p. As soon as you drive a car off the lot, it begins to depreciate in value. If you buy a pre-owned car for $5,200, assume its salvage value, V, depreciates according to a method called the double declining balance, basically 80% each year, and is given by the function V of t equals 5,200 times 0.80 to the t power, where t is the time in years. Step A. Find V prime of t. Step B. Interpret the meaning of V prime t. Step A. In order to find the derivative of the equation, use the formula d over dx times a to the x equals ln a times a to the x. Using the equation, we find that the derivative v prime of t equals 5200 ln 0.80 times 0.80 to the t power. Unfortunately, there is a high divorce rate in the United States, and it is approximated by the function d of t equals 100,000 e to the 0.025t, where d of t is the number of divorces occurring at time t, and t is the number of years measured from 1960. Step A. Find the total number of divorces from 2000 to 2011. To solve this, view the year 2000 and 2011 as your limits. Determine how many years from 1960 each is. Your limits are 51 and 40. Now, find the integral of your original equation. After that, plug in your limits for t and solve. Step B. Find the total number of divorces from 1960 to 2012. To do this, use the same process from step A, but change your limits to the number of years since 1960 of these two values. Your limits are 52 and 0. Find the integral of your original equation again, and again, plug in your limits for t and solve.